Okay, this video is about net ionic equations. If you're in my general class, this is not going to be on your test. If you want to watch the video and learn it, I'm totally cool with that, but this is only going to be tested for honors kids. So a net ionic equation tells you who's actually involved in the reaction. Who's actually doing the work here and being involved. There's some ions inside of a chemical reaction, and they are called spectator ions. Those are ions that are kind of just sitting there watching what's happening. Okay, so I'm going to teach you how to do those. I'm going to use the example that we used in our notes. So if you look at your notes paper, you should be able to follow along with this. So you're going to be given a chemical reaction, and there's 3 steps to doing these reactions. These problems. So the first thing you need to do is make sure you have a balanced equation. So I'm going to go ahead and I'm just going to go through and do this in my head. I have 1 aluminum on the left, 1 aluminum on the right. That's happy. I can move on. I have 1 acetate right here. Guys, acetate is C2H3O2. But I have 3 acetates on the right side. So what I'm going to do is I'm going to multiply this acetic acid by 3 so that acetate has 3 on both sides. I'm going to go back, double check my aluminum. My aluminum is still happy. Now my acetate's happy. I can move on to my hydrogen. Well, I have 3 hydrogens on that left side, right? 3H, because acetate is its own thing. But I have 2 over here on the right side. So what I'm going to end up having to do is multiply this H2 by 3, because the least common multiple is going to end up being 6 hydrogens. So I'm going to change this one to 6 now so that then my hydrogens are happy. But now I need to go back and double check my acetates. So on the left side I have 6 acetates now, but on the right side I only have 3. So I'm going to go ahead and I'm going to multiply by 2 to make that acetate happy. So my hydrogens are happy, my acetates are happy, but now look at my aluminums. I have 1 aluminum on the left and 2 aluminums on the right. So what I need to do is go ahead and multiply that left aluminum by 2 so that everybody's happy here. So my coefficients here are 2, 6, 2, and 3. So that's your first step. Make sure you have a balanced chemical equation. Your second step has to do with these guys right here, these guys in parentheses. So these guys in parentheses are telling us what, essentially what state these reactants and products are in, okay? The most important ones to us right now are the ones that say AQ. Some people call it aqueous. Other people call it aqueous. I'm one of the people that says aqueous. Sorry if you're judging me. Get over it. Either way, I personally think is fine because I've heard professors tell me either way. So anytime you have solid, liquid, or gas, you're not going to touch the element. You're just going to bring it down as is. The aqueous here, though, we're going to split them up into ions. So split into ions. So I'll just kind of show what I mean and hopefully you'll be able to pick it up. So I'm going to start left to right, just like I read. So I'm going to say, okay, 2ALS. Well, I'm not going to do anything to solids because Miss M told me not to do anything to solids. Solids, liquids, or gases, just leave them be. Next, the aqueous, I'm going to go ahead and I'm just going to rip this ionic compound apart. So I know that in this acetic acid right here, I have a hydrogen and then I have an acetate ion. So I know that there are 6 hydrogen ions, and I know that a hydrogen has just a 1+ charge when it's an ion, so I'm just going to go ahead and say 6H+ aqueous. Then I'm going to say plus, and I actually have 6 acetates right here, so I'm going to say 6 acetates. And I know from the back of my periodic table, the acetate has a 1- charge. So I'm going to write it like that, and I'm going to say aqueous. I'm going to draw my arrow because that's what's next in my equation. And now I have another aqueous compound. So I'm going to go ahead, split it up into its ions. So I know that I have 2 aluminums, and I should know that aluminum has a 3+ charge because it needs to get rid of 3 electrons to be able to be happy at that full octet. Then I also know that there are 6 acetates here because I have 3 times 2. So I'm going to say 6 acetates right here, again with a 1- charge because that's what acetate is, and aqueous. And then finally, this 3H2, I don't really touch it because it's a gas, and the only people I'm supposed to be really touching right now are the aqueous ones. So step 2 is to just break that up as I showed you. Step 3 involves getting rid of your spectator ions. So you can think about being a spectator in the stands at the football game. When you're a spectator, you're just sitting there watching. You're not actually participating in the game. In my classes, I talked about spectator mode on Fortnite. You sit there and you just watch other people playing. You're kind of creepy just sitting there watching them, but you aren't actually playing the game. Okay, spectator ions are similar. They're just sitting there watching what's happening in the reaction. Okay, and so we just want to get rid of them because we want to see who's actually involved. So the way you know that there's a spectator ion is if it's shown on both sides of the equation. So for example, 6 acetates right here. There's also 6 acetates right here. They're on both sides of that arrow, so I can get rid of them. Sometimes there's multiple. In this case, there's only 1. And now once I've gotten rid of my spectator ion, I can go ahead and write my true net ionic equation, which is 2 aluminum solid plus 6 hydrogen 1 plus ion aqueous yields 2 aluminum 3 plus ion aqueous plus 3 hydrogen gas. And that is my net ionic equation. These aren't like the crazy hardest thing, but the worst part of it is you make one little mistake, boom, the rest of it is messed up. So hopefully that video helps.